Hello everyone, in this video we're going to look at how to use Nernst equation to solve some problems. For question number 1, over here, the question wants you to find the cell potential. So the cell potential, this is what the question wants. And we know that the symbol for cell potential is written as E cell. Since there is no word standard in front of cell potential, therefore for this question or situation, we have to use Nernst equation. Another clue that you can pick up to tell you whether you need to use Nernst or not, you can look at the concentration of the electrolytes. Over here, you can see that's the concentration of your electrolytes for the anode half cell is 0.10, and the concentration for the electrolyte for the cathode is 0.50 molar. Both of the concentrations over here are not at 1.0 molar. So if you want to have a standard condition, the concentration needs to be 1.0 molar for both of them. To start, we have to write out the step number 1. You have to look at the question given to you, find out whether the temperature will be at 25 or at temperature that is not at 25 degrees Celsius. Why? Because as you have learned in the previous video, that we have the Nernst equation and we have the simplified Nernst equation. If we have a situation like what we are looking now we have the reaction occurs at 25 degrees Celsius, therefore we will be able to use the simplified version of Nernst equation. If you prefer to use the Nernst equation and not the simplified version, that's okay. But over here, I'm just going to show you an alternative. If you have the question that has the temperature of 25 degrees Celsius, we can use the simplified version of Nernst equation, which is this one in the green bits. Okay, so do remember that you're going to use ln over here. If you want to use log, you can use the other simplified version, and that one you can look up in other reference books or you can Google it up. But in my opinion, it's better for you to make the simplified version to look kind of similar to the Nernst equation. In the Nernst equation that we have looked at in the previous video, you're going to use ln over here instead of log. So this is the simplified version. Remember, the reason why we can use this to solve question number 1, because the temperature is at 25 degrees Celsius. In step number 2, from the given, you are given cell notation. Okay, remember that is the cell notation. From the cell notation that is given to you, you should be able to write down the half cell reactions and the overall reaction for the reaction or galvanic cell given to you in here. Do remember that on this side, this is the anode, and on that side, that is your cathode. So how are we going to write the half and overall reactions? That's easy. So first we're going to write down the anode, then you get this. So you're just going to refer to what you have in here from nickel. So the nickel solid will be losing electrons. 2 electrons will be lost, and that is certainly going to be the anode half cell, because for anodes, that one will be the losing of electrons. Okay, oxidation is losing electrons, and oxidation will happen at the anodes. Remember the mnemonic red cat and oil rig when you want to decide which one is going to be the anodes and cathode. And when you look at the cathode part, you can see that the copper 2 plus aqueous will be receiving 2 moles of electrons to become copper solid. And that is exactly what is going on in here. You have a reduction process. So you have the Cu2 plus to be reduced to Cu solid, copper solid, because the copper 2 plus aqueous will be receiving 2 mole of electrons. So when you want to complete that by writing down the overall reaction, you will have this. Okay? So by writing this, you should be able to get 1 mark for here, 1 mark for that one, and you'll get 1 mark for the overall reaction. The reason why we need to have this information, because we want to know some information from the overall reaction so that you can substitute those equation or those quotient in here. Okay, and then we need to get some information from the half cell reactions so that you will be able to know what is N. Therefore, we can say that the part over here we will get from the overall, and N over there you will get from the half reaction. So what are the information that we can get from what you have done in here? Let's have a look at the information from the overall equation first. So from the overall equation, we should be able to find out the information about this, the quotient that we need to get for your simplified Nernst equation. And from the overall reaction here, we can see that the quotient should be concentration of Ni2 plus aqueous over concentration of Cu2 plus aqueous. Remember, solid, both of them will not going to be involved in the quotient. This is exactly like what we have done in the chemical equilibrium that we have learned in the past. So you're going to write it like this. And the question gives you the information about the concentration. You can see that's right over here, 0.10. And the concentration for Cu2 plus aqueous is given in there, 0.50 right there. And this is the quotient that we need to put in here. What about the information from the half cell equations? So the information that we can get from the half cell equation is how many electrons will be flowing inside the galvanic cell. Okay, so when you look here, you have 2 moles of electrons going to be lost from the anodes. Remember, the electrons will be flowing from anodes to your cathode. And how much? 2 moles of electron. So you can say that the electrons going to flow from here to there. So how much? 2 moles of electrons. So 2 moles of electrons will be lost from the anodes, and 2 moles of electrons will be received by the cathode. So that's why you have 2 moles over here, and the mole of electrons is 2. Okay? It is incorrect if you're going to assume that the number of mole of electrons is 2 plus 2. That is incorrect. I repeat, that is incorrect. Wrong. 2 plus 2 equals to 4. If you put 4 over here, that is absolutely wrong. Okay, so we want to know how much of the electrons are going to be flowing in the galvanic cell. So you have 2 moles of electrons right there. So now you have found out 2 moles of electrons. Okay, so you get 2 marks over there. And next, what you need to do, step 3, we need to find out the E0 cell value. So you're going to use this equation, E0 cell equals to E0 cathode minus E0 anode. Okay, remember, this is standard cell potential. And when you look at what the question gives, the value over here, and also nickel, just now, like what we have talked about, this is the anode, and this one is the cathode based on the question. So your copper will be the cathode, so the value, that one, we're going to put it in there, and your nickel, the nickel that you have in here, nickel half cell, will be the anode. So you're going to put the value of your nickel standard reduction potential in there, and you will get the E0 cell value. By doing this, you would be able to get 1 mark and 1 mark right there. So what we need to do now, since you have got all of this information already, you know that we can use the simplified Nernst equation because the temperature is at 25 degrees Celsius. And we know that the quotient is written like this. And the question gives you the information about the concentration. And we know that the number of mole of electron flowed in the galvanic cell is 2 mole. And we have found out the E0 cell value is plus 0.59 volts. So we're going to use all of this information that we have already and insert all the values in the simplified Nernst equation. You will be able to get your E cell value equals to positive 0.61 volts. Okay, so you're going to put all the values inside. In here, you have the E0 cell. So that is the value of E0 cell. So I have written it down over there. And the value of N, you have N equals to 2. So you're going to put 2. And the quotient is this. Replace that with this. And you're going to substitute the value inside. So you get this. So when you solve this, you will get your cell potential value. So that is the cell potential value here, and you'll get 1 mark for this, and this whole thing 1 mark. Now let's have a look at the second question. For this one, it gives you the information about the anodes, which is lead, and this anode's electrode is immersed in 1 molar solution of lead nitrate. And you have a platinum cathode that has gaseous hydrogen bubbling over at a pressure of 1 atmospheric pressure. So that is the SHE. The hydrogen ion concentration of the solution is 1.3 times 10 to the power of -5 molar. From that information itself, we know that this is a non-standard galvanic cell. The question wants you to predict the spontaneity of the reaction. So we're going to use the Nernst equation to know whether this is going to be spontaneous or non-spontaneous. Step number 1. So as usual, you need to identify what equation you need to use. So in this case, we're going to use Nernst equation. Okay, why? Because since the temperature is 35 degrees Celsius, we're going to use the Nernst equation and not the simplified. Remember, if you want to use a simplified version, the temperature needs to be at 25 degrees Celsius. But in here, you have temperature that is equal to 35 degrees Celsius. We're going to use this. So when you want to use the Nernst equation, you need to know what is the value of R. You need to work out the temperature in terms of Kelvin, and you need to know what is the value of Faraday's constant. And what you have is here. This is what you need. So the R value, which is a constant, is 8.314 joule per Kelvin per mole. The temperature is given 35. Change that into Kelvin. Very important. Okay, so that is the most important bit. You need to change it to Kelvin because in your R constant, you have Kelvin in there per Kelvin. And your Faraday's constant is 96500 Coulomb. You're just going to substitute in there. Moving on to step number 2. Again, we need to find out the half and overall equations. Okay, so the anode, as what you have been told, you have a lead anode immersed in 1 molar solution. So you have it in here. So you have lead, Pb, okay? Pb solid, the lead solid, which is the electrode, will be losing electrons, okay? Because anodes is oxidation. Oxidation is losing of electrons right here. Remember, red cat, oil rig. So the next bit is cathode, which is your SHE. It's right over here. It says you have platinum cathode, gaseous hydrogen bubbling over it. You have pressure of 1 atmospheric pressure, and hydrogen ion concentration right there is given. So the purple bit is going to be your cathode, and your cathode is your SHE. By completing that, we will be able to write down the overall cell equation, which is here. You have lead solids plus 2H plus aqueous to be producing lead 2 plus aqueous plus hydrogen gas. So the information you're going to get from the overall equation will be the quotient. Okay, you want to get the quotient over here. Okay, remember, we have done this just now. So that you're going to get from the overall, and N over here, you're going to get from the half reactions. So by looking at your overall over here, the one on top will be the concentration of Pb2 plus, okay, because you have products over reactants, you have products Pb2 plus times the pressure of H2 gas, because we are dealing with pressure right now. So you can work that out with the concentration, no problem. And the question gives you these information, okay? So for the reactants, you have 2 moles of H plus aqueous. So that's why you have to the power of 2. Over here to the power of 1, because you have 1 mole of Pb2 plus and 1 mole of H2 gas. You need to remember that one, okay? So the to the power of 2 over here, because you have 2 moles of H plus aqueous. Therefore, the quotient will be written in this form. And the information from the half equations, you will get the information about the number of mole of electron float in the galvanic cell. So you have 2 here, and the answer is 2. So you'll get 1 mark for that, 1 mark for cathode, 1 mark for the overall, and 1 mark for identifying the number of mole of electrons float in the galvanic cell. To continue with that, you're going to write step 3, which is finding the E0 cell, so the standard cell potential. We know that this is the reactions. You have the anodes, the lead as the anodes, the SHE as the cathodes. So we want to find what is the E0 cell for this. So by doing that, you're going to do this. So you're going to take the value that you have in here. Do you remember? The question says that this is going to be the anode, and your SHE will be the cathode. Substituting the value inside, you'll get the E0 cell value positive 0.13 volts. This is the E0 cell value. So we're not done yet because we need to predict spontaneity for something that is at non-standard condition. So you'll get 1 mark for this and 1 mark for that. And to predict spontaneity, you have to use E cell, because right now the concentration, one of them is not at standard condition. The whole thing over here is non-standard. Therefore, in step 4, we're going to insert all the values in your Nernst equation. We have identified the Nernst equation we want to use. We have identified the R value, the F value, the temperature we have worked out in Kelvin, and we know that the quotient that we need to use is this. You're going to substitute the value inside, and we know that 2 mole of electrons are flowing, and E0 cell we have done that just now. And all you need to do now, you have to take all of these values, insert inside your Nernst equation. Then you'll get something like this. Okay, so when you try to work that out, you'll get the E0 cell value equals to negative. So you have negative value over here. So that one will be 1 mark. This is 1 mark. And is it going to be spontaneous or non-spontaneous? So in step 5, you're going to conclude, since you have a negative value over there. So you're going to write, since the E cell is negative, it's a non-spontaneous reaction. So this, you'll get 1 mark. And for that, you will get another 1 mark. So that's how you're going to predict the spontaneity. Next, we're going to look at question number 3. This question wants you to find the pH of the solution. And you are given the overall cell reaction above, right there. And also you have the temperature for the cell potential. You have the word cell potential over here. That means we need to use Nernst equation. Remember that. So we have cell potential mentioned. So with that, we know that this whole thing right now needs to be solved by using Nernst equation. Other than that, you are also provided with the concentration of the electrolytes, which is 0.1 molar. Another evidence that this question needs to be solved by using Nernst equation. And the pressure of the oxygen gas. And you have below here the SRP values for both half cells. To start, we need to identify what type of Nernst equation we need to use, whether you can use the simplified or not. As mentioned, we can see that the cell potential is at 25 degrees Celsius. To start, we need to look at step number 1, which is to identify which Nernst equation we need to use, whether we can use the simplified version or not. When you look in the question, just now we have identified that the cell potential is at 25 degrees Celsius, which is 0.04 volts. Therefore, we can use the simplified version of the Nernst equation. Moving on to step 2, from the overall cell reactions that we have right there, we will be able to find out what are the half equations. And from there, we will be able to work out the information from the half equation and also information from the overall equation, just like what we have done in question number 1 and question number 2. So these are the anode half cell and cathode half cell. When you try to look at the overall cell reaction above, we should be able to work out the half cells reactions. This is for the anodes. Bromine will be the anodes because when you look there, this is the one that will be losing electrons. You have the electrons in the beginning when the Br minus on the reactant side. When it moves to the product side, it will lose the electrons. And for the O2 gas plus 4H plus aqueous, these are the reactants to make the water liquid. And to do that, you need to receive or you need to gain 4 mole of electrons, just like what we have written down in the cathode's half cell reaction down here. So you're just going to write the overall cell reactions as what you have been given in the question. From the half cell reactions that we have produced right there, we should be able to find out the information about the number of mole of electrons flowed in the galvanic cell. Okay, so from there, we can know that how much electrons are flowing in the galvanic cell. So when you look right here, they are 4 moles of electrons flowing in the galvanic cell. Okay, so you have 4 mole of electrons, like what you have seen right there. Okay, so by writing the correct anode's half cell, you get 1 mark, cathode 1 mark. Okay, you will not going to give 1 mark for the overall cell reaction because it is already given to you in the question. So this is the important bits right there for the half cell reaction. We need to know how much mole of electrons are flowing. So we have 4 moles of electron. So you have 4 moles of electron donated by the anode half cell and will flow to the cathode. Okay, 4 mole of electrons. And from the overall cell reaction, we should be able to find out the information about the quotient. Okay, so you have the concentration or the pressure of products to the power of X over concentration or the pressure of reactant to the power of Y. Why do we have 1 over here? Because when you look at the product side over there, both of them are in liquid form. And as we know, pure liquids and solids are considered constant. So it will not going to be part of the quotient here. So you're going to put 1. But when you look on the other side, for the reactant side, we have oxygen gas. So we're going to put the pressure of the oxygen. And you have concentration of H plus to the power of 4. And you have concentration of Br minus to the power of 4. So this is the quotient that we need to write for this particular galvanic reaction. The question gives you these information already right there. I'm just simply writing that down here so that it will be easier for you to identify what are the values you need to plug into your quotient. And this is what we need to find. Okay, the concentration of H plus, we need to find this. By finding out what is the concentration of H plus, we will be able to find out the pH of the solution. Moving on to step 3, from step 2, we need to find out what is the E naught cell of the reactions that we have in here. Okay, so we're going to use the E naught cell equals to E naught cathode minus E naught anode equation. And from the question, we know that the anodes will be your bromine right here. And the cathode, you have your oxygen gas. Okay, so we're going to take the SRP value that you have in here. I'm going to try to highlight that with the correct color. So that is going to be your cathode. And this is going to be your anode. So you take that value, you're going to put that into your E naught cell equation. 1.23 volts, 1.23 volts. Why? Because this is the one that will be the cathode. Minus with 1.07 volts. It's 1.07 volts for this half cell, because this is the one that will be the anodes based on the given overall cell reaction above, and you will get your E naught cell value equals to positive 0.16 volts. So by writing this equation, you'll get 1 mark, and by getting the correct E naught cell value, you will get 1 mark. Next, what we need to do is we need to insert all the values inside the simplified Nernst equation, and you take all of these values that you have identified just now to find the H plus concentration. Okay, so you substitute everything inside just like this. Okay, so you have the 0.16 volts right there, and you have 4 mole of electrons as what you have identified from the half cell equations. Okay, 4 over here. That is the value of N. And you're just going to substitute the quotient that we have identified right here into there. All right. And you should be able to solve the whole thing, and you'll get your H plus concentration. So this is the H plus concentration when you solve this mathematically. Okay, so you get 1 mark for this, and you will be able to get 1 mark for the whole thing right there, and obviously 1 mark for the number of mole of electrons that you have identified in the beginning. Okay, we're not done yet, because the question wants you to find the pH, okay, pH of the solution. Now we have found the H plus concentration. We're gonna go for the final step, which is step number 5. We're gonna use the formula pH equals to negative log times concentration of H plus. So you're just gonna simply substitute the value inside the formula here, like what we have done before, and we will be able to find the pH of the reaction right there. So by doing that, you will be able to get 1 mark for the formula and 1 mark for the pH that you have found. For the next question, this is going to be the last question for this video. And this type of question is quite popular in exams, in which they want you to find the equilibrium constant K from the galvanic reaction given to you. So let's say this reaction will be done at room temperature. So when you look at the temperature, you should be able to know that the Nernst equation that we can use is the simplified version. So you need to always keep that in mind. If we have a different temperature than 25, then we need to use the full version of Nernst equation. Please take notes of that. And then moving on to step 2, since we need to find out the equilibrium constant K, we have to identify what are the values at equilibrium. So this is slightly different from what we have done in question number 1, 2, and 3. So at equilibrium, you need to know that the quotient right now, so the reaction quotient that we have over here will be equals to your K equilibrium constant. By writing this in exams, by writing this particular information, you will get 1 mark. And the second value that you need to know at equilibrium is the value of the cell potential. So at equilibrium, the cell potential will be equal to 0.00 volts. And for that, also you will be given 1 mark when you write these 2 pieces of information. So in step 3, we have to look for the value of N. Okay, so the value of N, as what we have done just now. First, you need to find the anode half reaction, and you need to identify the cathode half reaction. I'm just going to write the overall reaction over here, although to get the value of N, you simply need to look at how many electrons are flowing. And what we can see here, you have 2 moles of electrons flowing in the reactions that we are given in the question. So we have 2 moles of electrons flowing in the galvanic cell. So by doing this, by writing that, you get 1 mark by identifying the number of moles flowing in the galvanic cell. In step 4, we need to find the value of E naught cell, like what we have done for question number 1, 2, and 3. Therefore, we're going to use the E naught cell equals to E naught cathodes minus E naught anodes. And from the question, we know that the value for E naught cathodes and E naught anodes are as follows. Then when we look at the question, we know that the value for 0.80 will be the cathode, and the value for 0.34 will be the anodes, as what you have been working on just now for the full reaction equation or the overall cell reaction. And for that, you will be able to get the value of E naught cell. You'll get 1 mark. You'll get 1 mark for this equation, and you get 1 mark for the value of E naught cell. So in step 5, we're going to take all the values that we have worked out before we reach the step. We have identified which Nernst equation we're going to use, and we're going to use the simplified version because the temperature is at 25 degrees Celsius. And we know that the reaction quotient will be the same as the equilibrium constant. And at equilibrium, we also know that the E cell value will be 0.0 volts. And that is the E naught cell value that we have worked out just now. And we also have identified the number of mole of electrons flowing in the galvanic cell. So taking all of those into consideration, we're just going to substitute all the value inside the simplified Nernst equation, and you will be able to identify the value of equilibrium constant K. So you're going to put all the value inside as what we have identified over here, and you'll get the value of K. You'll get 1 mark for this, okay, and 1 mark for that.